Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight we're really excited to bring to you some activities that your algebra students will love. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight we're really lucky to be joined by our two panelists, Deb Nutt and Marion Prince. Deb has been in education for over 30 years, teaching all levels of algebra at Salina High School for 26. During the late 90s, she started using TI technology to help students better understand math concepts. In 2007, she became a T-Cubed instructor, which has allowed her to keep up with the newest TI technology and pedagogy. Since then, she enjoys helping other teachers by leading TI workshops and presenting at local, state, and international conferences. Deb, thanks for joining us tonight.
Thanks, Mike. Thanks, everybody else, for joining us, and hopefully we'll have a good evening.
And before and after becoming a T-Cubed instructor over 20 years ago, Marion has taught multiple math and science subjects ranging from grades 6 through 12 in a variety of school settings and a variety of roles besides classroom teaching, including Title I Math Science Specialist, all the way to a founder and coordinator of a STEM magnet school, and that was before the term STEM was even part of our vocabulary. After completing a doctorate in curriculum and instruction, she transitioned into adjunct teaching for several universities and coaching for the local middle school FTC robotics team. Marion, thanks for joining us tonight.
It's great to be here, and I'm hoping that everybody learns something.
We're expecting a large crowd, so feel free to send any questions to Marion or Deb using the Q&A window on the right side of your screen. Since we are expecting a large crowd on, though, your audio is automatically muted. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try turning the audio broadcast, toggle that on and off. At this point, Marion is going to discuss our agenda.
Yes, I'm so glad that we're welcoming everybody. I see people from all over the U.S. that contribute to the chat. Thank you for attending, and we're going to be doing algebra activities where we're going to catch a ball in a can using algebra, and Deb is going to show how her students investigated car prices and put some mathematics to that. And please stick around. We invite you to participate in the webinar drawing that Mike will conduct at the end, and it includes a T-Cubed free conference registration, and the T-Cubed International Conference is just around the corner in February. It is a virtual conference.
Absolutely. Absolutely, yeah. And by joining tonight, joining us live, everyone is automatically entered into that drawing. And Deb is going to discuss our expected outcomes.
All right, looking at our goals and outcomes for tonight, we're going to look at some exponential decay with the use of car depreciation. The catch the ball works with the transformation of parabolas in analyzing that parabolic path for a projectile. We're also going to observe and some of the features of the TI-84 plus CE or any of the TI-84 family of calculators, looking at regressions and tracing and evaluating functions and things. So again, hopefully you will learn something new here tonight and maybe walk away with an activity that you can take back to your own classroom.
Deb, thanks so much. Marion, you have control. Feel free to share your screen.
Okay. All right. Let me start the slideshow, and we're going to be using the graphing calculator to catch a ball. And for Algebra 2 students, this assumes that they've done transforming parabolas or other functions and can manipulate the vertex of a parabola with their equation. And you see in front of you, and for Algebra 1, we use the x-intercept form, whereas the Algebra 2 uses the vertex form. And this remarkable piece of technology that I built from things bought at Lowe's, you can see, I'll show you some close-ups, but it's just 1x4 pine material with a hinge, some steel bracing. I did have a friend of mine put a V-groove into the boards to seat that molding, and so it would bend, and it was held in place by some steel braces. And I'll show you some close-ups, but the object is there's a magnet up at the top, and you take the magnet off to drop the ball down, and hopefully it will land in the can. And the can is, I always raid the science teacher's ring stand and clamp. If I can't get a clamp, they always have a ring holder. And so I make a piece of cardboard to hold the can on the ring holder. And these are available at the store at Lowe's. And I used a empty Bush's bean can and drilled a hole in the bottom and proceeded from there. And you see in these close-ups, I just used a very strong magnet that held a half-inch steel ball bearing. And you can see in the middle picture there is a right angle clamp that you can put the magnet on top and the ball on the bottom. The third picture on the right shows the hinge that holds the two 1x4, and these pieces of wood are about 28.5 inches long, each one, and the brace would hopefully ensure that it's a right angle. And you can see that this corner molding is available at Lowe's. This is a close-up of where the steel ball, the middle picture, is showing the end of the grooved ramp. And this is a straight brace, and it's keeping it's below the bottom edge of the groove so that the ball will flow freely and be in a horizontal path off the end of the ramp. And you see my lovely Bush's Beans can, and I used I-screw plumb so that it would make it easier for students to place the center of the can. And also I used the same in the picture on all the way to the right. It shows I used string with the I-screw as a plumb bob so that the students could measure where the end of the ramp is and make it easier for them to make their measurements. And I measured this particular table that I was on was 73.5 centimeters tall. And before I go on, do you have any, Mike, or do you see any questions about just the stuff that I made this out of?
Marion, I don't see any questions just yet, but if any pop up, I'll let you know.
Okay. And as a side note, this activity I first saw in a middle school workshop that was a week long about various textbooks that had just come out, connected math and math in context. And this was one of the activities that we did on the middle school level. And I thought it was just so neat, I adapted it to high school level as well. Now, the rules of this activity are that the students have 3 trials without the can, and they can take whatever measurements they need to. They can measure the height of the table. They can measure whatever they think is necessary to figure out where to put the can to catch the ball. And so, you know, we prior to this, I might have studied parabolic motion, trajectories, and of course, transforming parabolas on a middle school level. We would have studied the x-intercept form of a parabola. And so this is a short, extremely short video, like 3 seconds, to show you how the ball went out. And you'll see in the bottom on the floor, you see there's a piece of carbon paper there. I have a tape measure that's lined up with the eye screw plumb. And this makes it more accurate measurements for students, because they can, if they're careful, it will mark where the ball lands, and they can measure how far away from the table it lands on the floor. So listen carefully. You probably won't be able to see the ball, but it bounces on the carbon paper. Fortunately, it landed in the box, the open box. That was an accident. They usually roll all over the room, so you have to put something there to stop the path of the ball. But I'll play this several times. You can hear. I'll play it again so you can hear the ball hit the carbon paper, and I'll show you what the carbon paper revealed in just a second. So you simply, to release the ball, it's just lift the magnet and you look at where it landed. And I have a close-up. I did 3 trials and I measured in centimeters. I find it's somewhat easier for students to measure, although you're welcome to use inches as well. But those 3 trials were fairly close. I measured the distance that those points were to the plumb bob. And so this would be a hypothetical, pretend this is the results of one group of students. They measured the bottom of the ramp. It's 73.5 centimeters above the floor, where the ball is when it goes into free fall. And from the distances were 80.2, 81.7, and 81.8. So now I'm going to ask you, do you have paper and pencil? If you do, and you want to see where you would put the can, and in the interest of time, in the classroom, I don't tell the students how far away to put the can or the ring stand with the can, and I let them decide. But for time's sake, I put the can 60 centimeters from the end of where the ball leaves the ramp. how high should the can be? So I'm going to give you some time. I better look at my clock there. I'll give you 5 minutes. I think that should be sufficient. 5 minutes. How high should that can be? Assuming you're an Algebra 2 or an Algebra 1, you can use either the vertex form or the x-intercept form of a parabola. So do you have any music, Mike?
Right, I'm thinking of maybe, the Jeopardy theme song. I'm
Yeah,
playing it in my head as we speak.
Right. No, I've had real excitement in my Algebra 2 class. If you can listen and do your calculations, and, assuming that not everybody's doing the calculation, but I heard you two, because pretend you're a student and you want to catch that can, because I always bribe my students with either Snickers bars or candy bars to the winning group or the top 3. But my worst section in Algebra 2, all but one group caught the ball. I was totally amazed. I did not expect that at all. I expected my good group every group to catch the ball. But it turned out that my worst group, they were low performing. About half of them did not have the skills necessary for Algebra 2, but to do this activity, they really got motivated.
Hey, Mary, we have a question from Patrick.
Yes.
Patrick just want to know, how tall is the can again?
Oh, well, you can place it. The height of the can does not matter, because you can place the top of the can where you need it. So you need to calculate, okay, can I get here's my can right here. Where is the top of the can? You can place the center of the top of the can where you want it. And if your algebra is right, you can place that ball in the center of the top of the can. So it doesn't really matter how tall the can is. But that's an excellent question. I hope that answers.
Yeah, I think we're good.
We have 1 more minute. Let me know if you need 30 more seconds or more than 30 seconds. Oh, I had a question about place the can at the, oh, no. The can, you're limited to putting it on the ring stand. The ring stand is not as tall as the table. So no cheating. Putting it just at the end of the ramp, no. You have to put it on the ring stand. And if you'll notice from the picture, the ring stand is very short. Okay, I'm going to see, and if you will send, if we put the can 60 centimeters from the end of the table, how high is the top of the can? where do you put the center of the top of the can? What is the y coordinate? If you would share that with Mike. Mike, see if you get some answers sent to you. Let me know when you get a few.
Yep. So we have, so far I saw one from Dave, 33.5 centimeters.
Uh-huh.
Raymond said 33.9 centimeters.
Uh-huh. Oh boy, we're getting
33.9. David said 32.25.
$33.3.
Yep. Michael.
All right. This is the, somebody used 81.5 as the landing. Yeah, 80, yeah. Okay. Here's a sketch. On the left is an Algebra 2 solution using the vertex form. And the main task is to find out what the value of P is, which is the distance from the vertex to the focus of the parabola. Your H and K, those the horizontal and vertical transformations are 0. If you put the vertex where the ball comes off, and so you find that using this coordinate system, your y coordinate comes out to be the distance below the table, the top of the table, so you have to subtract from 73.5. And on the x-intercept form, of course, your 81.2 is your x-intercept, the x-intercept, and so you need to calculate the value of A, the coefficient, and you get here the origin is at the bottom, right below the edge of the table on the floor. And so you get 33.4, and depending on how you round it, you get 33.9 or 33, excellent job. You got it. And this is to show you that 33.4, and the key to this is measuring placing the center of the can at the coordinates that you calculate, or that the kids calculate. And that's the trick, mainly because the algebra is going to be correct. And in watching this video, it's very fast. You have to listen because you'll hear the ball land in the can. And the thing is you tell the kids beforehand they only get one shot to make it in the can after they, collect their data. You won't be able to see but you'll be able to hear it land, and I'll give you some close-ups afterward. You watch the can. Let me do that again. Watch the can. You can see the towel kind of crunch. You hear me. But I did take a close-up. You can see the ball here in the top center, and then later on it's off the ramp, and then you can see it is there, honest. I did catch the ball in one try. But I only have another minute or so, but if there's any other questions or any comments, what feedback do you have? I'll take a pause here before I give the control to Deb. Oh, yes, regression. Thank you very much. I didn't see who said that. You can use regression, and let me go back. There we go. Because you can put in the coordinates of your 3 points and do a regression and get the equation in standard form. You're welcome to have your kids do it that way. I have not done regression. I've even done this with 8th grade students. I did not use regression with the 8th grade students. And yes, the activity is available because they will be, Mike, you can clarify where they get the materials. I have the worksheet, the teacher notes, and if you're can't remember how to do these things on the 84 Plus, I have step-by-step instructions for that. And let's see, where did I put them? I have the step-by-step instructions for how to do the regression as well if you want. And I also show how to use the home screen to evaluate what y coordinate would be associated with an x coordinate of 60. You could use the home screen with 8th grade, but these documents are available. Mike will tell you how to get them, and he may have already provided you with a link with them. Any other questions?
That's great, Marion.
Okay. And let me stop sharing and pass the control. Deb, I'm hoping that it goes to you.
Yep. Okay, I think I just got it. Did it come up? There we go. Right. This is a project and an activity that I've done with my Algebra 2 students. And our school has 3 different levels of Algebra 2. I started out as a full, complete project with my honors students. And what I'm going to show you tonight as far as the handout is something that I would have given to them. I've also used it in just regular algebra. I've used it in the basic algebra too, where I give them some of the data and they work with a partner and we do it in class, and they don't do a whole written up project and things like that. But it's how much that car in the driveway, and it's the project I think my students like the most. My honors kids are sophomores, so they're just turning 16. And in my area, it seems like when they turn 16, everybody's getting their own car and things like that. So it was something that they could relate to. They knew they were going to be driving soon. It was something that seemed very practical to them. Again, you're going to be getting a copy of this handout. And again, you can use it in all different forms and things like that. But basically what happens, the students had to pick a make and a model of any vehicle they wanted. And again, I let them totally choose. It could be what their family car was. It could be their dream car. It could be what was sitting in the driveway. In my area, again, I live in a rural area, so there was lots of pickup trucks involved and things like that. And I basically have probably had just about every make and model of car over the years that had this. I had students that did the family vehicle. I've had Corvettes. I even had, it seemed like every year there was at least one Lamborghini that got turned in. So, I let the students pick whatever they wanted. What they had to do was to find actual prices of anywhere from 12 to 15 vehicles that were not to be more than 10 years old. And again, this was done strategically so that some of the years would be duplicated. Again, because we're looking at a line of fit and what might be a good fit. I've also had to learn through trial and error not to allow Kelley Blue Book. Again, I did this through trial and error because One year, someone used Kelley Blue Book for most of their prices. And let me tell you, that comes out to a perfect regression if they use Kelley Blue Book prices. It's very easy today to get 3 different sources because of the internet with the new Carvana and, the CarFox. I try to encourage the students to maybe call a local dealer as well and see if they could actually find something sitting on a lot close to home and stuff. We only have 2 dealerships in my small town, but they would try, or they could call up to a larger city and see if they could get things. So they had to get prices of actual automobiles that were for sale. And once they did that, using their 84 calculators, we made a scatter plot of their data. And then we worked with an exponential equation, and we found a line of fit. And again, I talk about using guess and check. In my classroom, I never talked about and used regressions for data like this because I wanted the students to learn what the different values did within an equation. So then they had to do find a line of fit in an equation and provide that equation. And then I also included some questions at the end using their work. With the honors kids, again, they actually wrote up a full paper, typed it up, included their graphs and their scatter plot, their line of fits, all of their calculations that they did. I provided them a table where they could record their information. And then these were the questions, and we'll look sort of at these questions again later as well. But we talked about what is the domain and the range of the scatter plot. I wanted to make some conclusions about the scatter plot, and I learned over time that sometimes it's a good thing to say that they have to give me at least 3 conclusions. And in my classroom, if I say that I want at least 3, if you give me 3, that means you would get a C on that part of it, because at least means there's probably more than that. So I always try to give them a goal, and they learn really quickly that if I say at least 2, anything more than 2 is better. Then using your line of fit, what would the price of a 12-year-old car be? And if you had $8,000 to spend, what age of car might you be able to buy with that particular amount of money? So trying to do some applications of that idea. So that's the project in general. Again, this would be a full-blown project that I might give to the honor students. With my lower level class, I might give them some data and just in class use a partner and come up with the scatter plot and a line of fit on their calculators, and then do paper pencil calculations with questions and things like that. So Mike, has there been any questions about the general project itself?
Nope, nothing that I'm seeing just yet, Deb.
All right, thanks. So what I had, sorry, go ahead, Mike.
Sorry, I was just saying thank you.
Okay. What I thought we'd do tonight is sort of look at one. This is a set of data that one of my students had for a Honda Accord. This is the data that they collected on the age of the car and the different prices. One of the things I did with the full project, they had to include a picture. So I just went to Google Images and I found this Honda Accord that could be just copied and pasted and things like that with it. And this is the data that we would put into the calculator. So going to my Smart View to put that data in, again, I would go to the Stat key and I would use the Enter. And to save a little bit of time here tonight, I've already entered this data. And again, just to show you, if I slide this over, you can see that in list 1 and 2, oopsie, sorry about that. List 1 and 2, I've got my ages of the car in list 1, and I've got my different prices listed in list 2. And I just, to save time, did that this evening. Now, the other thing that, of course, has to happen to make the scatter plot is we have to turn it on. So on the calculator, I'm going to go to second stat plot. I'm just going to turn on plot 1. I always have to make sure to hit the Enter key so that it actually gets turned on. The scatter plot is the first type of graph. My years are in list 1, so I'm okay for that for my x-axis. My prices are the y list in list 2, so everything seems to be set up for that. One of the other things that I always do is once we've turned on the calculator, of course, we have to set up the grid itself and what size do we want. Another thing that I never did in my classroom, because this is usually in Algebra 2 is about the first time that we did a lot of calculator work, and I never used and talked about the zoom fit or zoom stat, especially with something like this, because if you do that, you're just going to be hanging around somewhere out there in that first quadrant. And there is really no then known idea of where we are. And if we're going to put in a line of fit, we need to have some form of reference. So one of the rules in my classroom is we always had to see the X and the Y axis on anything on their calculator before they could turn in their information. So we always use the window and set up our dimensions. And again, it makes the kid think a little bit more about what their domain and their range was instead of just letting the calculator do it. So my X's were my years. And again, just to make sure that I have my axes showing, I'm going to go from -1. I'm going to make my my maximum go out to about 14. I think the scale of 1, a tick mark every space would be okay. My Y, I'm going to leave at -10. The maximum, I think I need to go up to about 2,400 or 24,000 to be able to get all the prices in, if I remember right. And with that in mind, I probably better make my scale at least 2,000, if not 3,000. Again, one of the nice things about the technology is if you don't like the tick marks and there's not enough of them or there's too much space, you just go back to the window and you change it real quick. So hopefully we've done everything. I've got the data in through the stat key. I've turned on the plot and said we wanted a scatter plot, and I set up the size of my grid. And so now I hit my graph and I have a scatter plot. And that doesn't look too bad. I might increase my Y maximum just a little bit because that one point is fairly close to the top. So I think I'm even going to go all the way up to 2,600 just to be safe. Gives me a little bit more space. And again, remember that one of the things in the project, one of the questions was to talk about the scatter plot and what does the domain and range represent and what observations or conclusions can you make about it. And hopefully what happens there is they talk about whether it's a function or not a function as far as a scatter plot. They talk about it does seem to be descending, but maybe not at the same rate. Hopefully that they notice there's a little bit more vertical space between this point and this point than between the points down here at the end of, or to the right-hand edge of the scatter plot and some things like that. So looking just at the scatter plot, making some conclusions. Again, Mike, are there any questions or anything?
I saw one question from Valerie, just asking how long did you give your students to complete the project for both maybe an honors class and a regular class?
For my honors class, if they were doing the full-blown and the full-blown project, I would explain it, and it might have been like 2 weeks, and basically it was all done outside of class. They might have had to come in to print off and pull off their plots to put into their paper and things like that. So I had a couple of computers, or they could go down to the library and things like that. So I tried to give them enough time. They could work on it instead of doing the daily homework in class. Sometimes I'd bring in the magazines that you can find in restaurants that would have car prices on them and things. And so they could look up if they didn't have a lot of internet research available and things like that. But I would say 2 weeks should be enough. Again, this was usually a fourth, close to the end of the year working with exponentials. So they'd already done some projects and they were used to it and things like that. You could do in the basic class, I would basically do a day. If I was giving them the information, like if I gave them the list of data from a particular vehicle and all they had to do is a scatter plot and a line of fit, we could get that done in a basic class period, maybe 1.5 class periods, depending on the length of time and things like that. So it depends on what you want to do with it.
I saw another question. Getting your students ready to do an activity like this, what are some things that you maybe have them do to get them ready for this?
I don't know. Once you pass it out and you start talking about, we would have done lines of fit and maybe done something in class, maybe not with exponentials, but again, this would have been towards the end of the year. We would have done all kinds of things throughout the year, whether we started with a linear project, and again, with a linear, we did an in-class one where it was a Monopoly game board, and they had to find the prices of the properties compared to the spaces from Go. And so we did that as a group project in class. So they were used to doing these because of having done the in-class work and having, problems in the book that were, here's a set of data, can you find a scatter plot and a line? So they would have practiced in other ways, but this brought into them actually doing the numbers and doing the complete mathematical process instead of just getting data from the page in the book. And so I hope that answers that they would have been used to, and we, started out with group work, started out just doing one altogether in class back in Algebra 1 and things like that.
So whenever students do this, do you think has it worked better with them working individually or maybe like working together as a group?
Both work. It depends on how much time I have in the year. Maybe and again, it depends on the level of the course. I would do the group work more with the lower level. With my honor students, I pass it out, take half a class period to explain it, and they're off and running. So it depends on the students as far as that goes and what level course it is and what your ultimate objective is. I mean, even sometimes with the honors class, we do it and they bring in data, but time-wise, I don't have them type up a whole, paper and turn it into me, because there's nothing I like more doing over Memorial Day weekend sometimes than grading 30 of these projects that have come in, or I should say 60 of these projects that have come in so that I'm ready before finals week to pass them back to them and things like that. But there's been many 500, Indianapolis 500 race that I've set out and graded some of these. Going off topic. All right, how do we do my line? Because I said I don't do a regression. We could do it through guess and check, which is how I started years ago doing it, where we just typed something into y equals, graphed it, see if it looked, made adjustments. That became a little cumbersome. And then I learned about the transformation app. And the transformation app that comes preloaded on all of the 84 calculators is a very powerful tool. And so I want to go through that. Some people are a little familiar with it, but may never have used it in this way to do a line of fit. Okay, so I'm going to go to the apps key. I'm going to use the up arrow because the transformation app is usually the last one that's listed alphabetically. And I just hit enter. It takes me to a basic introductory screen, and it says to use any key. And so when you do that, it takes you back to the home screen, and it doesn't look like anything happened. But if I go to my y equals, this is where you see things have changed. And it depends a little bit maybe on what version of Calc 84 you're using. On the gray screen, you won't see this, that it says you're in the transformation app or your quit app. And depending on what version, even on the color calculator, what you see to the left side of the equal sign. Excuse me. The older versions will have this funny looking symbol on every one of the entry lines. On this newer version, it's only the first two lines. What that means is that these are the entries where you can put in some formulas that you're going to manipulate or that you're going to transform. And again, that means I can put in two different formulas. Of course, only one can be turned on at a time. But what TI has done recently is allowed us to then enter other ones, and I can play match the graph with this. And I can put a formula in line 1 or 2, and then I can put other equations hidden in the other ones, and we can play match the graph. So to put in the formula, I'm going to go to the left of the equal sign and see that it's highlighted. If I hit enter, you get this pop-up. And again, this is in the newer version. It might not have that capability. I'm going to change the color because my scatter plot was in blue, and I'm going to use a different color for my line. And our school colors were green, so I use green a lot of the time just to keep kids interested. Excuse me. Down in this line where it says Y1, right now it says no, but when you go down to it, you see we can go right and left. Again, the newer version has some preset formulas that you can just cut and paste. There's the linear, there's like 3 different forms of the quadratic, there's a cubic form, and a couple of different forms of that, absolute values, sine, cosine, and tangent. And these are just now preset so that you don't have to type them all in as a little bit of a time saver. If you're in that no area, you can type in anything that you want in the formula that you want. So as we go through and we look at these again, you see that we don't have this exponential form. So I'm going to have to type in our formula that we're going to use. So I just go down to the OK. So you see I'm in green now. I'm going to go to the right. When you are typing in formulas, you have to use the first 5 letters of the alphabet only for a formula. So you have to use A, B, C, D, and E. One of the things that I was worried about when I first started using the Transformation app is whether students would be able to, like with linear, can they make the connection from mx plus b to ax plus b? And it really was no problem whatsoever. And, we teach HK for the vertex form of a quadratic. Can we have B and C in there instead of H and K and have the students understand what it's doing? And they have absolutely no problem with that. The other thing that you might want to do is to make sure that everyone's starting with the parent function. So if I go to the Windows and then up to settings, I'm going to start with my A at 1 and my step, since it's this exponential as 2, I should say my B, and a step of 1. So then when I hit graph, I still have my scatter plot, but now I have this parent function in here. You see the formula at the top of the graph, and you see that I have my variables down here. When the equal sign is highlighted, and if you use the up or down arrow key, it changes it. So I can change, and I can change one of the values at a time. To change the value, I can use the right and left arrow key. If I want to increase my A, and now I'm at 4, and you can see each time as soon as I do that, the graph moves. The other thing is that I can actually type in a number. So I could type in 100 and then hit enter, and it changes it. I wanted to change the B value, and I don't really want to go into the negative area. And again, because my Y scale is so large, it doesn't look like my B value is changing too much as far as intercept and things like that goes. So what this does is allows us to write on the graph screen, sort of guess and check and see what we need to have. So if I'm thinking of this exponential equation that's going to have to come down and curve through my points, it looks like my Y-intercept is going to have to be up here. And if I count my tick marks up, I think I'm at about 2,400. So which of the variables is going to be the 2,400? Do I need to change the A to that, or do I need to change the B to 2,400? And hopefully some people are putting that into the chat. And if you're not sure, and I shouldn't say 2,400, I should say 24,000. And so I changed my A value to 24,000. It looks like I've got an intercept up here now. But now I need to get my line over here in quadrant 1. Right now I have the B value of 5. If I need to move it from over here to the left of the Y equals and into the quadrant 1, B value would be in my students I know how my students think. Their first guess is, oh, I need to flip it over to the other side, so let's make B negative. So if I put in -2, oh, my line totally disappears. Well, we got to remember this is an exponential. This is something that only shows up in quadrant 2 and quadrant 1. So if larger values like 3, 4, and 5 didn't work, negatives didn't work, what's going to have to be used? And again, you might put this in the chat window. And hopefully we've got some people thinking about not integers. And I know how much my students love fractions. They never think of fractions. But if I start with someone that said between 0 and 1, with 0.5, at least I've got it in the right area. Now, it's not close enough to my point, so what do I need to change? And what do I need to change it to? Do I need it closer to 0, or do I need it closer to 1? And again, if you're not sure, you can just real quickly type something in. Oh, 0.7 moved it closer. Wasn't enough. Well, it moved it some. Let's take a bigger jump and go to 0.9. Oh, 0.9 was too much. And you can see how quickly with the transformation app, all right, things work. I'm going to try to be a little more specific. Let's go with 0.85. That's not too bad of a curve, except it's a little on the low side. So let's change my y-intercept now, and let's raise the whole line up and see what does 2500 look like. Let's go a little bit more. And we can get, by typing in numbers, you can get as accurate as you want. And I think what I came up with in my example that I used was a 0.87 for my B value and 25,500. So that it looks like I've got 1, 2, 3, 4, 5, 6 points below. I've got 5, 6 above. These couple are a little further apart. These couple are a little further apart. Now, the students are saying, is this good enough? And you're the mathematician. You're the one that has to figure it out and how accurate what you want to be. The first time I did one of these, how accurate does it have to be with guess and check? I had 2 of my football players who were sitting side by side. They sort of got into this contest, and all of a sudden they were going like 5 and 6 decimal places out because they wanted to be more accurate than their person sitting next to them. And so, I mean, when kids got excited, hey, mine's more accurate than yours, and mine's going to be more accurate because I'm going to now add another decimal point. I just got excited when the kids got excited about being that accurate with it. So any quick questions on the transformation app? I do have a handout for the transformation app as well that you'll get that sort of goes through the quick process of how to turn it on, where you can find these formulas, a quick screenshot that shows a formula and that you can type in values and things like that, a reminder of only using the variables and not necessarily using M and things like that with it.
Yeah, Deb, I would say the one question I've noticed that's come up a couple times, and I'm hoping you can talk to this, is, again, when should we use regression, when should we not use regression? When is that a good choice for your students versus not? Again,
until, like 10 years ago, regressions weren't talked about and weren't in the standards too much. So I sort of grew up teaching without talking about regressions and just lines of fit, and sort of waited for the pre-calc classes to talk about the regressions and what's more accurate. I know regressions are in the standards now at a lower level. Once we've gone through this, and I think my students feel confident about what the different value or variables do within an equation, then talking about the regression and that it really is the best fit. But then you got to get into that whole discussion of what is the R. And, talking about a regression is more, to me sometimes, doing a regression to see which is a better fit. Is a quadratic better, or is a cubic better, or is a power regression better because of what that R value is? And again, a lot of times using the regression in the stat courses to save time so they're not having to do the guess and check because they want that R value to be very close.
For Deb, for those football players, the one way that I've answered those questions about which is the closest is to just show them those squares, the residual squares on the Inspire, and just show them how the squares, it gets to a minimum, and you don't have to talk about regression at all. You just say, hey, you want to minimize those errors and leave it at that, and you don't have to use the word regression.
Yeah. That would work very, very well. Going back and real quickly looking at things and talking about the end of the project. Again, this was just the scatter plot. Here was the line. If we go back and we look at the questions, if I can get to the right spot here. These last two questions, and whenever I did a project that involved real data like this, I tried to put something like this in using the equation of your line of fit. How would you calculate something that would be 12 years old? See if I can get a pin to come up here. Great, didn't do what I wanted it to do. To do something that's 12 years old, I'd have to use the equation for myself. Y would be 25,500 times pin. Now I've lost a pin. 0.85 raised to the 12th power. And my pin has not working. There we go, 0.85 to the 12th. And then my other question, and this is where the real mathematics comes into play, the last question was if you had 8,000 to spend. So I would have to use the equation of 8,000 equaling that 25,550 or 500 times 0.85 raised to the x, and it's not going to work on me here tonight. Sorry, folks. Of course, that means they have to use logarithms in their calculations since they're finding that exponential. So again, doing some paper pencil work, and again, if I was doing the project with the honors kids, I would totally make them, they could turn that in and, you know, as part of the project in ink rather than having to type it up and get everything raised in logarithms and subscripts and all that kind of stuff. So that's a quick look. It looks like we only have about 3 minutes, so I think I need to pass it back over to Mike. Any other questions as I'm trying to get that done?
I think the one I just saw pop up that I can answer pretty quickly is if you don't have the app, or I noticed, I think someone earlier had said that they feel their calculator is a little bit older, and so they might not have all the features that you had tonight, Deb. All the information about updating, that's all free. We have videos on our website and tutorials for updating your operating system, for transferring apps from our website, again, to your calculator. That's all, again, available on our website.
Yeah, and again, the transformation app should be on every one of the 84 calculators. It's a matter of whether there are just 2 entry lines or it's every entry line. On older ones, you might not have those preset formulas that you can just cut and paste. So that's one reason why I chose the exponential, to also show how you can type it in. You can type any of those preset ones in as well. So if you don't have the newest version, you can type in the formula that you want as long as you are using the variables A, B, C, D, and E.
Thanks, Deb. So we're really excited that this year the T-Cubed International Conference is really coming to you. It's all virtual this year, so it's coming to your house, and it's going to be spread out over 3 weekends in February 13th, 20th, and 27th. As Marion mentioned at the beginning of the webinar tonight, we're giving away to one lucky winner a free international conference registration, and tonight's lucky winner is Michael Locker. So, Michael, congratulations. We'll be in touch in the next couple of days, to give you some more information. But we hope to see Michael as well as everyone else at the T-Cubed International Conference. Again, feel free to visit our website to learn more information. To receive a certificate of attendance, please go ahead and click the link that just appeared in the chat window. Also listed is a link for the documents for tonight. And if these links aren't working for any reason, just hang tight. You'll automatically get a follow-up email within a couple of days. And that follow-up email will contain links to the certificate, the documents, and also the recording from tonight. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. So big thanks to Deb and Marion for everything you put together tonight. It was really great to see so much excitement about these two activities. So again, thanks so much to the two of you for putting this together.
It was a pleasure.
Yeah, no problem. I hope everybody got something useful out of it, and it was good to have everybody join us.
Absolutely. We hope to see everyone back online next week. Have a great night, everyone.